Right, hello, my name is Joe Brock and I'm here to show you how to use some very basic kit to measure some very simple things. Once you can measure length and mass and time, then we can do just about any physics experiment with just the kit that you can see in front of you here, which is a very small, very lightweight bag, a syringe to measure volume of water, which you're going to take at 1 gram per cubic centimetre, a ruler, a pivot here, which could be anything, could be even a pencil, it doesn't have to be something flashy like that, we're just going to use that here today, and a rock with some string. So we're going to start off by measuring the mass. We intend to measure the mass of these various different rocks and use those as known masses at a later stage. We're going to label those up and put the actual masses on the rock themselves. So here we go. We're going to get our lever, our ruler, and place it at 50 centimetres, at which point it should balance with a bit of luck. I'm going to place our rock on the ruler, let's say at the 20 centimetre mark. Now that's at 70 centimetres, which is 20 centimetres from the pivot. Now I'm guessing the centre of mass of the rock, so I'm having to guess it being about the 70 centimetre mark here. And then I'm going to take this nappy sack, hang it on the end here, and fill it full of some water. So it's not really going to stand anywhere until I get some water into it, so let's do that for starters. So here's my syringe, up to 20 millilitres, 20 cc's, that's 20 grams going in there. We've got a very lightweight sack, and the idea of that is we're treating it as negligible, the mass of the sack. So that's 40 grams. Let's squirt that through air in now. Right, 60 grams, you can see it's starting to overbalance now. So I'm going to put that there, put the top on this, and don't tip it everywhere. And then I'm going to move this back towards the pivot until we get a balance point. Make sure it's on 50 still. On there, so let's do it 20. Oops, I get in the way. Oh, that's actually starting to balance quite nicely there. Oh, that'll do us actually. Now I don't know if you can see this, but this is about 80 centimetres there. 80 centimetres, which will be 30 centimetres from the pivot. Okay, so 60 grams, 30 centimetres from the pivot. So we're going to go to the board now and do a little bit of maths. And as you can see, we've got our 60 grams at 30 centimetres, our mass of the rock, unknown rock, at 20 centimetres. So anti-clockwise moments equals clockwise moments. 60 grams times 30 centimetres for M1, D1, and M2, M1 here times 20 centimetres here, which is an M1 of 60 times 30 over 20, M1 of 90 grams. Now that's done quite quickly, so let's see how well that looks on our very, very expensive top band balance, which you don't need to have because you've got this gorgeous bit of kit here. So I'll just take the rock across now. So predicting a mass of about 90 grams here. You place the rock on our top band balance, and we're getting about 88 grams, or around up to 88. So within about 2 grams in 90, so 2%, maybe a little bit more than 2% error there. And we're in a bit of a rush, so that's not bad. You could do better than that, probably get it within half a gram if you pushed it. So we now label this mass And do the same for a range of different rocks, labelling their masses each time, and now you've got a mass set, and you can use that to measure the mass of various other things, simply with a 1 metre rule and a pivot. Now we're going to go on to look at some other things. We can already measure the length of things. Of course, we've got a ruler. We can measure the mass of things because we've got a lever law, and now we're going to measure time using a pendulum. If I can get it to stay in its little saddle. I'm going to get a rock again, act as our pendulum bob, and tie it to our pendulum. And again, we're going to use a very simple formula to find out timing of things, timing devices. I'm not sure I managed to do that at all actually. Is that going to stay in there? It's not going to behave itself, is it? Okay, have another go at that. Let's tie that in. Rock. Yeah, I'm making it proper here, but let's have a go. Now we measure the length of a pendulum. We need to measure it to the centre of mass, and for a rock, this rock is quite a regular shape. We're going to have to take a punt at where it is really in terms of its centre of mass. But if I use a pendulum formula, which I'll write on the board in a second, we know that a 0.25 metre pendulum has a swing period of 1 second. So using my ruler again, I'm going to measure my pendulum length. Now I'm going to have the centre of gravity here as 25 centimetres now. I'm taking a guess at the centre of mass here. 25 is 10, 20, 25, so I need to make a mark on my pendulum at that point. But for now I'm just going to put my finger at it, and now we've got a pendulum. Thank you. Mark that out, 25 centimetres with a pen. Now I've got a pendulum which has got a time period of 1 second. That's 1, 2, 3, 4, 5, 6, so on. Okay, full swing is 1 second. If I measure long time periods, then I can count the number of swings it takes, and if it does half a swing, if I measure something that takes between 1 and 2 seconds or 4 and 5 seconds, then I reckon I can measure down to about a quarter of a swing accurately, which gives me about a quarter of a second accuracy, which is great. But there's something clever I can do. If I'm measuring shorter time periods, I can adjust the length of this pendulum to have a period of exactly the time it takes for a shorter time period to happen. And once I know I've got it the same time right, I can measure the length of this pendulum again and use a formula I'm about to show you on the board to find the time for a shorter time period. So let's just have a quick look at that. Time period of a pendulum is 2 pi root L over G, where G is the acceleration due to gravity, 9.81 metres per second squared. And so I can rearrange this formula as I need to, or once I've got my length, I just plug my length in, but remember length must be in metres. So if I just did that down to, let's say, 10 centimetres, that would be 0.1 metres. I plug it into my formula and get a value for time. And it's amazing how accurate you can get this. You can be down to sort of 0.1, 0.2 of a second if you need to. It's really rather good, and so you don't need a stop clock to measure time. The pendulum works really well. It just takes a bit of practice. So we've got length with our ruler, we've got mass using our lever law, and we've got time using our pendulum. So with those three things, you can measure just about any experiment you want to do in practical physics up to at least GCSE and possibly to quite a lot of A-level, advanced level teaching.